Hello and welcome to our video on solving for missing sides using similar triangles. I'm just going to do a couple of examples, one sort of simple one and one a bit more difficult. Usually the questions start off by telling you that the triangles are similar in some way and that you have to find one side from one of the two triangles. So in this case we have triangle ABC being similar to, that's what that symbol means, triangle FED, which tells you that angle A is equal to angle F, and that angle B is equal to angle E, and that angle C is equal to angle D. That order that those are written in tells you something about which angles are equal to which, and also which sides are going to correspond with which sides. So I went ahead and I just drew some symbols to show that the angles are the same. So you can see I used 3 lines here and 3 lines here to show that F is the same angle as A. Likewise, you can see the 1 here and the 1 there and the 2 there and the 2 there. I've also color-coded them for you. Now the next thing we want to do is we just want to work with the corresponding sides. So the side that corresponds with an angle is always the one across from it. So to show this, I'm going to try to match the color. So you can see we have a purple symbol there. So the side across from that, I'll just kind of put a purple line. And then the side across from the purple on this one, I'll also put purple line. And then for the orangey color angle, I'll use an orange line. And then for the blue, I'll use a blue. Okay, this will just make my life a little bit easier because it'll be easier to tell which sides correspond to which. Now, the thing that we've learned about similar triangles is that the ratio of corresponding sides is equal between the similar triangles. So if we look at the blue over the orange in this triangle, so the blue and the orange, we can look at the blue and the orange on this triangle. So if we do blue, okay, over orange on this side, and we do the same thing over here, then those two ratios will be equal. So we do blue over orange. So in this case, the blue side is the x we're trying to find. So you have to make sure you have the side that has your unknown in it. And our orange side, we know the measurement for, which is 12, this one. And we know that's going to be equal to the blue on this side, which is 2, and the orange on that side, which is 5.2. Now, the way that we've been working with this to solve is that we said that what we can do is move numbers diagonally across the equal sign in a process called cross multiplication. So what I'm really doing is I'm really multiplying both sides by 12. Okay? Which would give me 12 divided by 12, which is just 1. So this would just be 1x. So really I don't need that on that side because it'll just effectively get rid of the 12 there. So I'm just going to think about it as moving the 12 up here. If you like to think about it the other way, that's okay too. So then on this side I have x, because the 12 is moved, and I have 2 times 12 here over the 5.2, which is going to give me 24 over 5.2, which I can't easily do in my head, so I'm just going to bring up a calculator. So 24 divided by 5.2 is equal to 4.62 when we round it. Now, this will be a common thread throughout these videos. Just be careful, right? This has meters as its unit, so our answer must also be in meters. Okay, so what did we do? We made sure that we understood which sides correspond. I used a labeling system. You might not have different colors, so then you might want to make this like a wavy line and this like a dashed line. And then on this side, this would have been a dashed line and this would have been a wavy line. And then you would have been doing wavy, wavy over dashed. Now this one's sort of a classic example. It's a little bit different. The question normally says that these two lines are parallel. So the line here and the line there are parallel, which tells you that this angle is the same as that angle there, and this angle is the same as that angle. So now what you can do is you can just cut the top of this off. So I'm just going to cut this one right off the top and redraw it down there. And then we're going to think of the whole triangle as another triangle. We're going to draw that over there. And instead of trying to find x right away, I'm going to try to find this whole length here, which I've labeled y. So basically I just cut off the top to make two triangles. Now this goes with this. This is actually the same angle because they're both coming from up there. So we'll just give that 2 lines. And this one we'll use 3 lines. Okay, so this side will give a wavy line. And this side will give a wavy line because they're both across from the 1 line. And then this side will give a dash. And this side will give a dash. So our ratio is going to be wavy over dash. So in our small triangle, wavy over dash is 10 over 6. See, 10 is the wavy and 6 is the dash. And on our bigger triangle, we're going to have our wavy is y over our dash is 8.2. So once again, we're going to use our cross multiplication method to finish this off. So we're going to take this 8.2, I'm going to move it up there. Remember that we're multiplying. And we're going to get 10 times 8.2 over 6 will be our y. So again, you can either try to do that in your head or use your calculator. 10 times 8.2 will be 82. Okay, so we got 82 over 6 is equal to y. Whenever you have over, of course, you're dividing. So 82 divided by 6 is equal to 13.67. Now, I was saying be careful about the units, but you'll see here these numbers didn't have units, and so you don't need one for your answer. So there's kind of an easy one and a hard one for solving for similar triangles. Good luck with your practice.